Store connector builds a widget based on the state of the store. Before the build callback of store connector is run, the converter callback will convert the store into a more specific view model, which has the data and functions needed to build the widget. Every time the store changes, the widget will be rebuilt. However, this can adversely affect the performance as your app grows. As a performance optimization, the widget can be rebuilt only when the view model changes. In order for this to work correctly, you must implement the equality operator and hash code for the view model, and set the distinct option to true when creating your store connector. Then, the store connector will compare the previous view model with the current view model and rerun the builder if the two view models are different, that is, rebuild the widget. This means that setting the distinct option to true does not automatically mean performance optimization. It is obvious whether the primitive types such as integer or string we commonly use are equal or not. However, defining the equality for collection, classes, and mixed types of these is not so simple. Theoretically, looking at equality is somewhat difficult, tedious, and not easy to remember later. So let's look at it one by one through an example. I made an app called Distinct1 and installed Redux, Flutter Redux, and Equatable. And I uncommented the avoid print false line in the linter rules section of the analysis options.yaml file. As you can see on the screen, Distinct1 app displays the current counter value in the center of the screen. And there is a button that increases by 1 and a button that increases by 0. Pressing the button that increments by 1 increment 1, and pressing the button that increments 0 doesn't increment the number. If you think in common sense, if you press the button that increases by 1, the widget should be rebuilt whenever the number changes. And if you press the button that increases by 0, it seems that the widget should not rebuild because the state does not change. Since it is a simple app, the basic skeleton of the app has been created in advance, so let's take a look at it together. The counter state to be dealt with in this app is a primitive type integer. I mentioned before that the state is made as a class as much as possible, but this time, for the purpose of examining the distinct option, I use a primitive type as the state for a while. I declared an integer type store as a late final variable. Create a store inside the main function. As argument to the store constructor, we give a reducer and an initial state with a value of 0. We'll look at reducer in a moment. We wrapped the material app with the integer type store provider and gave the store created above as the value of the store argument. I deleted the My Homepage widget, which was originally a stateful widget, and recreated it as a stateless widget. In the build function, it returns a scaffold, and the body is given a center widget. The column widget is given as a child of the center, and main axis alignment.center is given as the main axis alignment so that the widgets in the column are placed in the center. Text widget is provided as the first child of a column, and currently string 0 is displayed in headline 1 size. As the next child, I gave a size box with a height of 50.0. Next, we give a row widget to horizontally arrange a button that increments by 1 and a button that increments by 0 as a child. Main axis alignment.center is given as a main axis alignment so that the two buttons can be centered. As children, I created two floating action buttons. The button's callback is currently an empty function. The title of the first button displays +1 with font size 20.0, and the title of the second button displays +0 with font size 20.0. Next, let's look at the actions. I have created two actions in the actions.dot file. As the first action, I created a class called increment1 action, and as the second action, I created the increment0 action. As the name suggests, when increment1 action is triggered, the state is incremented by 1. And when increment0 action is triggered, the state is incremented by 0. That is, there is no state change. Next, let's look at reducer. Reducer receives integer type state a dynamic type action and creates a new integer type state. First, if the action type is increment 1 action, the state is incremented by 1 and returned. If the action is increment 0 action, 0 is added to the state, that is, the original state is returned. And in the default case, the state received as an argument is returned.